Hi, we will now see Laplace transformation, the transformation visually and its use in solving differential equations. What is Laplace transformation? Waveform equations can be transformed from one domain to another domain, from time domain to space domain, from one set of numbers to another set of numbers. The set of numbers we call this as a domain, this is another domain. Function of functions, it can also be called as a function of function. Ft is a function of time. You can use any variable x also, but this being a time function, periodic function sometimes, we call it as a ft. And the space domain is called, variable is called s. So Laplace transformation is a function of this function of t. It is called capital F of s. S is a variable, usually a complex variable. Now, Laplace transformation of function of t is defined as an improper integral of e power 0 to infinity, that's why it is called improper integral. Integral of e power minus st into ft into dt. For example, we will take ft as 1. It's a constant 1. So we can use this definition, integral of 0 to infinity e power minus st into 1 into dt. The integral of this is nothing but e power minus st by minus s. And putting the limits, when you put infinity, 1 by infinity is 0. And then when you put 0, anything power 0 is 1. Therefore, minus 1 by s is 1 by s. We will take another function, e power at. So the integral of e power minus st into e power at dt is, so I can multiply these two. So e power a minus s into t. Therefore, the integral is 1 by a minus s e power a minus st. Same as like this. Right? Here 1 by s, here 1 by a minus s. When you put the limits, it becomes 1 by a minus of 1 by a minus s, which is 1 by s minus a. Please note, s should be greater than a, otherwise this will not be possible. Right? A minus s will be negative, will not be possible. Now, we will take another function, sine of at. It is e power minus st, sine of at into dt. Let's say it's y. Now, integrating by parts. What is integration by parts? We'll see here. If differential of uv is u dash v plus uv dash, then we can integrate this and get this relation. Integral of u dash v plus integral of uv dash. From this, we can say that integral of u dash v is equal to uv minus integral of uv dash. Here, what we'll have to do is we'll have to find which one u dash, which one is v, and solve it. So e power minus st is u dash. Yeah. So u is integral of this minus 1 by s e power minus st. We know it already. And then v is sine at here. And then v dash we can find out. Differential of this is a cos at. Substituting, we will get this answer. This. So y is equal to, we have said it as y, no? So y is equal to minus 1 by s e power minus st sine at minus integral of this. Now we have to find out the integral of this. This we can solve it by integrating by parts. So we will see this, integrating by parts. In the next slide, we will see this. Now, we are using the same relation. What is u? U dash is e power minus st. This is the term. So u is minus 1 by s e power minus st. Cos at is v now here. And therefore v dash is a sine minus a sine at. Substituting, you will get this answer. So the answer for the second term is given here. Putting this back, y is equal to the first term is here. So a by s into 1 by s here. So for a by s squared, e power minus st cos at minus a by s into a by s. Therefore, a squared by s squared into. Please note, this is nothing but the original problem, y. Right. Therefore, we can simplify this y into 1 plus a squared by s squared. I have brought this term here back. Right. Y I am taking it. Y into a squared by s squared. I am bringing it to the left hand side, simplifying it. This is equal to right hand side. I am putting again 0 to infinity limit. So if you put infinity, the entire term will become 0 because e power minus infinity is 0. And if I put 0, it becomes 1, and this becomes 0, and this becomes a by s squared. Minus of minus becomes plus, is a by s squared. Yeah, because 0 is the lower limit, so minus of. Now, simplifying this, s squared plus a squared by a squared, denominator s squared gets cancelled on both sides. Therefore, the answer is y is equal to a by s squared plus a squared. So the answer is Laplace transformation of sin a t is a by s squared plus a squared. Now we have got one Laplace transformation. We can see this later visually. We will see how to solve this linear differential equation. Laplace transformation transforms, it turns all the derivatives of functions, second order differential, first order differential, third order differential, into multiplications of the basic function with the term S. That is a domain S, space domain. So L of f dash t, this is the first order differential. Laplace transformation of this is given by S into L of the basic function f of t minus the initial condition f of 0. Similarly, second order differential Laplace transformation is given by s squared into the Laplace transformation of the basic function. This is what is the beauty of Laplace transformation, which helps in solving the linear differential equations so easily. Now we will see this sin a t function here, basic function. When a is equal to 0, see here 0, it's a horizontal line. When a is equal to 1, it's a sinusoidal function. Right? One cycle is completed here. You will have a is equal to 2, more number of cycles are completed here. So frequency increases, time period decreases. A is equal to 2 here. Now what is the Laplace transformation is a by s squared plus a squared. You will see for this first for a is equal to 0 condition, the same thing. Right? So it is a horizontal line. And for this, the Laplace transformation is a power function. And for this again, a power function, it varies. Right? Now we will also see this in the form of animation, thanks to MapleSoft. MapleSoft has provided me the software. I'll use the software to explain this. We will see how to solve the linear differential equation. Step 1. There are 3 steps. Step 1 is take Laplace transformation on both sides of the equation. Then step 2 is simplify this. Step 2 is simplify to get the equation in the form of Laplace transformation of the basic function in terms of the ys, its variable, and then now solve it, taking the inverse. So solve using inverse Laplace, because Laplace transformation of basic functions we know it will be given in the form of a table. We can use that and convert this back. The inverse of this, we get this y of t. Inverse of this is y of t. Right? Now, before I say thank you, what I will do is I will show the animation part. Right? I'll stop sharing it. I'll pass the. Now see here, the function sin a t is shown here. When a is equal to 0, it is horizontal line. That is what you have seen. When I keep varying this a, you can see this. When I put a is equal to 1, I'm going to make this a changes. See, when a is equal to 2, this is a graph. When a is equal to 1, it is a simple graph. I keep varying, so it keeps on increasing. So this is a basic function. And for this function, I'm going to show you the Laplace transformation is shown here. This is a by s squared minus a squared. So I keep s for various s. You will have this a by s squared plus s squared function is shown here. So what I will do is, now we will see here. So we will see the transformation for this, transformation for this, transformation for this. Animation also we have seen. And we have also seen how to get this equation, linear differential equations, and solution of linear differential equations just in 3 steps. You are having the equations, taking the Laplace transformation on both sides, algebraic equation we get, simplify it, and then take the inverse Laplace, and you get the function yt. Thank you very much for watching. Please subscribe to my channel and view more educational videos. Thank you very much. Stop sharing.